Good morning, everybody. Happy Tuesday. Jumping into another video here. In this one, we're not going to look at another method of solving systems of equations, but we're going to analyze systems of equations so that maybe we can know a bit of information about them. And we're going to do that using our graphing calculator and solving the systems graphically. So let's jump in. Right on. Jumping into the workbook, page 621. And this one, we're going to look at determining the number of solutions to a system of equations. So there's actually three scenarios. When I give you two equations and I tell you to find the solution, there's actually three options, okay, of what could happen with those lines. So we're going to dive in, and we have this first example kind of explores those three options. Then we'll talk about them a bit more. Okay, so as part of a high school work experience course, 3 students have been placed in 3 different burger restaurants. Deha has been placed at Burger Shack, Shelly has been placed at Big's Burgers, and John has been placed at the Burger Haven. Detailed below are the first 2 orders taken by each student and the total cost calculated by the student for each order. So this is kind of similar to yesterday when we looked at I think it was admission prices to a movie or the carnival or something like that, where it was, this is the cost of an adult ticket, this is the cost of a child. Here, we're talking about the cost of burgers and salads. Okay, burgers and salads. So before we actually get going, I'm going to make a quick little statement and just say, hey, if I am talking about burgers, okay, I'm going to use the variable x. And if I'm talking about salads, I'm going to use the variable y. And it actually says that below in question A, but I just want to kind of get using that reference right off the bat. Okay, so instead of having to write burger, I can just write x. For the first order, Deha charges $28, total cost of $28, and that got 4 burgers and 2 salads. The next order was $34, and that was for 6 burgers and a salad, so 1 salad. Okay, go over to Big's Burgers. This was Shelly, $18 for a burger and 3 salads. Next order was a big one, $54. That got you 3 burgers and 9 salads. Okay. Finally, Burger Haven, $32 for 2 burgers and 4 salads, or $42 for 3 burgers and 6 salads. Okay, great. So these are 3 different scenarios we're looking at. We're going to look at Burger Shack using these 2 equations, determine the price of a burger and salad at Burger Shack. Then we're going to go over to Big's Burgers. Use these 2 equations, calculate the price, or solve the system. And then finally, we'll go to Burger Haven. So I'm actually doing 3 questions here, but what it's going to outline is the 3 scenarios. So let x dollars be the cost of a burger and y dollars be the cost of a salad. Write a system of equations for each scenario. Okay, Burger Shack, the first one. Okay, 4 burgers, so 4 x's, and 2 salads, so plus 2y, that was $28. So that's my first equation. 4 burgers plus 2 salads has to equal $28. All right. The other equation was 6 burgers, so 6x, plus a salad. So I could write 1y, or I could just write y, equals 34. Okay. Those are my 2 equations for Burger Shack. Heading over to Big's Burgers. This was Shelly. $18 for a burger, so just a single x, plus 3 salads, so 3y equals 18. And the other equation, $54. So maybe I can jump ahead and say, okay, this total had to equal 54. That was 3 x's plus 9 y's. Okay. Finally, hop over to Burger Haven. John charges $32 for 2 burgers and 4 salads. 2x, 2 burgers, plus 4y, that's the 4 salads, equals 32. And then the second order was 3 burgers, so 3x, 6 salads, that's 6y, and that was $42. Okay, so I have my 3 scenarios, and we're going to look at all 3 scenarios and solve. Okay, so first one is Burger Shack. Write each of the equation in terms of y. and then use your graphing calculator to determine the cost of a burger and the cost of the salad. Okay? Well, this is what we did yesterday. If I gave you two equations, 4x plus 2y equals 28, that's one of them. The other one was 6x plus y equals 34. I can solve graphically by typing them into my calculator, but in order to do that, I have to write it as y equals. And that's what it means by write in terms of y. So I'll do the first one. Okay, got to get the y all on its own. Let's move the x to the other side. Subtract 4x's. 2y equals negative 4x plus your 28. Divide by 2, divide by 2. You don't have a lot of space in your workbook for this, so you probably got to squeeze this in or maybe write it somewhere else. Negative 2x plus 14. Okay, and I'm going to call that y1. On my calculator, that's what I'm going to type into y1. Go over to the other equation, 6x plus y equals 34. All I actually have to do is move the 6x. I subtract 6x from both sides. Y equals negative 6x plus 34. Okay, and that's what I'm going to call y2. All right, so if I ask you to solve graphically, you tell me here's y1, here's y2, and then what you're going to tell me is the point of intersection. Okay, the point of intersection. So pull up my graphing calculator. Okay, go over to y equals y1 negative 2x plus 14, y2 negative 6x plus 34, and let's just go zoom 6. Let's see what we get with zoom 6. There's the first one, there's the second one. Fantastic. Okay, fantastic. So the blue one kind of comes down like this. Red one just a little bit steeper. And there is that point of intersection. Okay, I've got two different lines. They come together and they cross. And what I know from yesterday is that point of intersection is my solution. So I'm going to go second calc to find it. Second calc. Scroll down intersect or just press 5. It says you're already in the first curve. Well, I don't know. I can't actually see my cursor. It's going to move my arrows. Oh, there it is. I'm on the blue line. Enter. Second curve. Move my arrows. Oh, yeah, I'm on the red line. Enter. And then it asks me to make a guess, so I move a little bit closer. Oh, 5, 4. Okay. X of 5, y of 4. That is the solution. Okay. Which I know the burger was X, so maybe I can make a little statement. Burgers cost $5. Salads cost $4. Okay. At the end of this unit, we're going to look at kind of word problems and context, and we'll actually write sentences. For this one, it's just, oh, hey, I had my two equations. There were two different lines. Find where they cross. This is the point that satisfies both of the lines, so it's the solution. Okay. Let's jump to the next one. So I'm giving myself lots of space. Now we're going to go over to Big's Burgers. We're going to do those equations, which were x plus 3y equals 18. That was one of them. And the other one was 3x plus 9y equals 54. Okay. And I'm going to say, okay, I figured out for Burger Shack. Now let's go over to Big's Burgers. Okay. Rearrange to y equals. Move your x over. 3y equals negative x plus 18. And I have to divide by 3. Get rid of the coefficient. What I do to one side, I do to the other. So y1, my first equation, negative 1/3 x plus 6. Fantastic. Okay. Go over to the equation on the other side, or the second equation. Same idea, just maybe bigger numbers. Okay, move your 3x to the other side. 9y equals negative 3x plus 54. Okay, now I'm going to divide my coefficient. Divide by 9, divide by 9. And I get y2 equals, okay, I get 3 divided by 9. Negative 3 divided by 9. Well, as a fraction, 3/9, that's just 1/3. Okay, maybe I do that on my calculator. 3 divided by 9, math, enter. Oh, 1/3. Okay, plus 54 divided by 9 is 6. Okay, so I've got y1, y2. Got my two equations. One was from the first sale, other was from the second sale. Go to your graphing calculator, type these in. Okay, negative 1 divided by 3. That's a fraction, put it in brackets, x plus 6. Type in your second equation, negative 1 divided by 3, bracket x plus 6. And before I even hit graph, take a second to look at the two equations that we have. And maybe you're saying, well, it's not really even two equations. Okay, it's not really even two equations. So press graph. There's the first one. Oh, there's the second one right on top of it. One's like this, and one is like this. These lines are right on top of each other because they represent the same exact line. Negative 1/3 x plus 6, negative 1/3 x plus 6. It's the same line. Okay? They are the same line. Same line / equation. Okay? Oops. Same line / equation. So what happened was they started looking different, but when I actually rearranged, they're the same. And you can kind of see it, right? X, this is 3x. It's just 3 times bigger. 3y to 9y, oh yeah, it's 3 times bigger. 18 to 54, 3 times bigger. So it's just a multiple of it. Everything was multiplied. They represent the same line. So I don't know. There's no point of intersection. There's no one moment. Any moment, okay, could pick. So this, I was given redundant information. I was given information that was really the same thing. It didn't give me extra information. So I can't get the cost of the burger because this system is redundant, okay? In terms of number of solutions, okay, what I actually say, this one we did at the first one, there's one point that they share. A solution to equation is, well, how many points do they have in common? And this has one solution. This one has infinite solutions. Okay? Because there is never a point that exists on the blue line that isn't the same as the red because they're the same line. So at any moment, and keep in mind these things have arrows, so on and on and on, it will always be a solution because it's always the same line, so the points are always the same. Okay, so that's kind of a bad scenario to get. That's a system that I don't want because it doesn't give me any information. It's the same line. Okay, so normally we get things that cross once. That's my solution. By the off chance, I might actually get the same line, which is bad. It's redundant information. And that's an infinite amount of solutions. Okay, let's look at the third one. Okay, Burger Haven. Let's see what this type of solution looks like. So I had 2x plus 4y equals 32. That's the first one. The second equation was 3x plus 6y equals 42. Okay, equals 42. All right, now I'm going to rearrange, graph, go ahead and do all that. So subtract 2x, subtract 2x. 4y equals negative 2x plus 32. And divide by 4. What I do to one side, I do to the other. y1, my first equation, negative 1/2 x, negative 2 over 4, that's negative 1/2, plus 8. Okay. And then the next one, rearrange in a similar fashion. Subtract your 3x, subtract your 3x. 6y equals negative 3x plus 42. And divide by 6. Okay. So I get y2, my second equation, negative 1/2 x plus 42 divided by 6 is 7. I don't know why I'm doubting myself. Yeah. All right. Okay. Different equations. Whew. So I'm not getting an infinite amount of solutions. Okay. Maybe you look at them and you say, well, they're kind of close to the same equation, but they're not. So we'll see what that means. Okay. Negative 1 divided by 2, x plus 8. That's y1. Negative 1 divided by 2, x plus 7. That's my y2. Okay. Let's take a look at the graph. There's my first one. There's my second one. It's kind of interesting. Trying to figure out the number of solutions, right? But I don't see a cross. I don't see a point of intersection. So you think, okay, well, maybe I just need to extend this window a little bit more. Okay, and I can do something called zooming out. So zoom 3, zoom out. Zooming out from the origin. Yeah, that's kind of where I want to zoom out from. So enter. There's the first one. There's the second one. And they're not crossing. They seem to be kind of like train tracks. I'm going to go back to zoom 6. And then when I say train tracks, maybe that triggers a little something. These are parallel lines. Okay. The blue and the red line are parallel. They are parallel because they have the same slope, a slope of negative 1/2. I know lines with the same slope are parallel. Okay, so they will always just be slightly off. Always, always, always be slightly off. Okay, oops. Let me draw them. There's the first one. There's the second one. And I'm going to put these little arrows saying these are actually parallel lines. Okay. Same slope. Okay. Same slope. Therefore, they are parallel lines. Okay. Parallel lines. And I know parallel lines never cross. So you would have no solutions. There is never going to be a moment where these share a point because they're parallel. They're never going to cross. Okay? So those are the three situations I can get. If I give you two equations, there are three situations. Number one, the most common, okay? These are unique equations. They're not parallel. They cross, you get one solution. Okay? Most of the time, you're going to get one solution. All right? The second scenario would be, oh, well, it's actually the same line. Okay, it has the same slope, the same y-intercept. It's the same exact line. That will have an infinite amount of solutions. And then the third option is, well, they're almost the same line. Okay, they're parallel, but they have different y-intercepts. So they're parallel lines and they're never going to touch. Okay, and we're going to dive into that here. Okay, so here's an example, and we're going to look at the kind of situations. I really, if I'm asking you to solve a system, it will usually just have the one solution. Okay. The reason we want to know this is the question I'll ask you is, hey, here's a system. How many solutions does it have? Or how do you know how many solutions this could have? Or what would make this have only one solution or something like that? Okay. But if I ask you to solve, it's probably that good scenario where you're going to have the one unique solution. Okay. All right. Graph each system. Okay. And then state the number of solutions, A, B, and C. You know what? Why don't you do this ahead of me? A and B are set up for you to type right into your calculator. C, you have to rearrange one of them. So do that and then graph. But why don't you do all three of these ahead of me? Pause, and then we will finish it together.
A few moments later.
All right, so I went ahead and finished class example 1, and we see the three situations. Okay, you graph the first one. You can just type these right into your calculator. It looks something like this. I have one point of intersection, meaning one solution. Okay, if you want the math way to abbreviate solution, there it is. This is not a, don't put this in your English papers, but in a math class, you can abbreviate solution just like that. Okay, The second one, I graphed these. They're already rearranged to y equals, so it's pretty easy. Those are parallel lines. And maybe I noticed at the start, hey, they have the same slope. So I can kind of assume they're going to be parallel, or I know they're going to be parallel. No solutions. All right. And the final one, I had to do a little rearranging of that bottom of equation. But what I end up with is y equals 3x minus 2. And well, my other equation was 3x minus 2. So that's the same line, meaning I have an infinite amount of solutions. Okay. It is the same line. It's the same equation. All right. Let's jump down. Okay. We're going to take a look at this chart. And it says the number of solutions can be determined from the graph, or we can actually determine directly from the equations if they're in slope y-intercept. Okay. So let's go through the number of the solutions. Okay. I could have one solution. I could have 0 solutions, or I could have infinitely many. So infinity, just a sideways 8. Maybe you could do it all swoopy instead of just the 2 dots or 2 circles. Up to you. Okay. Oh, that's a bad one. Try that again. There's my infinity. Okay. It's like a sideways 8. So one solution. Okay. One solution. That is the unique scenario where they're just separate lines, right? So that's just one example. The point of intersection could be anywhere, right? But what I'm looking at is those lines have a different slope, okay? Those lines have a different slope. If I have the same slope, I'm parallel. I might even be the same line, okay? But if I have a different slope, I am good to go. Okay, I am good to go. The y-intercept I don't care about. Okay, as soon as my slopes are different, I know that they're angled towards each other and eventually they're going to meet. Okay, parallel, it says the slopes are equal. Okay, but the intercepts are different. So that one I do care about the intercepts. Okay, because the kind of one that goes along with that is for infinite solutions, the slopes are equal and intercepts are equal. Or really, what that means is it's the same line. Okay? That's where it's, hey, here's my first one. Hey, here's my second one right on top. Okay? Whereas my parallel, they don't touch. Okay? Those are 2 lines that are separated. They have the same slope, so they're parallel, but the intercepts are different. Okay? So just looking at y equals mx plus b, as soon as I have a different slope, I know I have one solution, and that's the most common thing. If my slopes happen to be equal, maybe I'm parallel, maybe I'm the same line, but we get that from looking at the intercept. Okay, so let's do that. Let's take a look at a couple and analyze the amount of solutions. So this is kind of the question I would give you is I'd say, all right, here are some equations. Are they, unique? Is it the same line? Are they parallel? Whatever. Okay. So the first thing I have to do is rearrange to y equals mx plus b. I could graph them, but graphing them requires to write them as y equals. So I'm really doing the same process. Okay. I'll look at this first one. Subtract your 3x, subtract your 3x. 5y equals negative 3x plus 15. And I'm going to divide that 5 away. Okay, divide by 5, divide by 5. I get y1 equals negative 3/5 x plus 3. The second equation is already good. y2 is negative 3/5 x plus nothing. Okay, plus 0. So then you have to say, all right, then you have to say, is it one solution, no solutions, or an infinite amount of solutions? And what I notice is the slope is the same, negative 3/5. Okay, so I'm going to say same slope which now eliminates one solution. It's either all the solutions, it's either infinite because it's the same line, or it's no solutions because they're parallel lines. These lines have a different y-intercept. Okay, the first line has a y-intercept of 3. The second line has a y-intercept of 0. Here's another math abbreviation. 3 dots in a triangle means therefore. So I said same slope, different y-intercept, therefore no solutions. Okay, no solutions. And I stated how I knew it. Okay, so all you'd have to say is 0 solutions, but it's nice to state why you know that. They are the same slope, but different y-intercepts, so they're parallel lines. They're never going to cross. Okay. X minus 4y plus 8 is equal to 0. Y equals 1/4 x plus 2. Let's do this one. Okay. Taking a look, I got to rearrange the first equation again. What I'm actually going to do is I notice that all 3 things are on one side. So let's just move the 4 over. Okay, the 4y. Save myself a little bit of work. Add 4y to both sides. Okay. 4x plus 8 equals 4y. And here's where I'm going to divide by 4. Divide by 4. 1/4 x plus 8 divided by 4 is 2 is equal to y. Or maybe you rewrite it the other way because that's a bit more comfortable. Okay, 1/4 x plus 2. Second one, it's already good. 1/4 x plus 2. You take a look at that thing and you say, well, wait a minute. Okay, same slope. 1/4 is my slope. And it's even the same y-intercept. This is the same line. This thing is perfectly, they're on top of each other. You would have an infinite amount of solutions. Okay, if I have the same exact equation, I know it's an infinite amount of solutions. All right. Next one, 7x plus y equals 12, x minus 6y equals 5. Okay, I got to do some rearranging for both of these. So let's go ahead and do that. Minus your 7x, minus your 7x. y1 equals negative 7x plus 12. Okay, good. That one's actually ready to rock. Next one might be a bit harder, but that's okay. Subtract your x, subtract your x. Negative 6y equals a negative x plus 5. And now I have to divide a coefficient. Divide by negative 6, divide by negative 6. y2 equals negative 1/6x minus 5/6. Okay. And there you go. And this one, I am happy to see, okay, they have a different slope. Equation 1, that's a slope of negative 7. Equation 2, that's the slope of negative 1/6. As soon as they have a different slope, I know it's one solution. Okay? As soon as they have, oops, put a box around that one. As soon as they have a different slope, it's one solution. Okay? I don't care about the intercept as long as the slope is different. Okay? So I'm just going to cook up a quick example of that because we didn't have one, right? If I had lines like, okay, y equals 2x plus 6, and then my other one was y equals 3x plus 6. And you might say, oh, okay, well, maybe that's not one solution because the intercept is the same. Well, no, the slopes are different. All I care about is the slopes. And really, okay, all that means is, as I go to my graph here, the y-intercept is my point in common. The slopes were different, so I know they're angled differently. As soon as the slopes are different, it's okay for these to be equal. Okay, and that just means, well, that's where my common point happens. So once you notice the slopes are different, forget about it. It's one solution. You don't need to worry. All right, so that's the kind of question I'd ask. I'd say, hey, here's a system. How many solutions do you have? Okay, and we can go from there. All right, last page of this lesson. It's actually kind of more of a question from last unit where it's all about the graphing and things like that. Really, maybe the only important part is it says, when you graph a system, it will be not visible using the default window. Well, yeah, we know that. I try Zoom Standard, but if Zoom Standard doesn't work, I zoom out, I change my window, I do whatever I can to find the appropriate window. So we're going to skip that one. Okay, there's your homework, 617-2458. And then you also have a check for understanding today. And that marks the end of the video. So make sure you get the homework done on that one. And you have a check for understanding today. It'll be a little short quizzes. And then, as always, ask some questions, send something in the Google form, set up a one-on-one appointment, smash the like button, hit subscribe, tune in again tomorrow, and I'll have another video for you.